Glad you're here. It is Friday, the 20th. Thanks for joining us for this live stream. My name is Brian Armentrout with the Food Leadership Group with my good friend Jose Sabal from sabalfoodsafetyconsulting.com. How you doing today, Jose?
I'm very well. Let me tell you that this week, due to the beautiful weather here in Southeast Florida, I
Uh-huh.
was able to go and ride my bike 3 times already.
Nice, nice. And we were talking a little bit before we went on the air here. Here in Colorado, as I look out my window, it is snowing.
Oh my goodness.
So I guess it's supposed to snow today into tomorrow. No real accumulation. It's too warm and things like that, but
Yeah.
just a weird late snowstorm. And so like my maple tree out here in front has leaves on it and things like that. So hopefully we won't get any damage. So that's it's kind of a weird thing. But let's see.
It's
Current
weird.
temperature, Jose, is 39 degrees here in
Right
Colorado.
now,
Yes.
oh my goodness. Over here, we have 84.
Crazy, crazy, crazy. Let's see. So our friend Renee in the Philippines. Nice to see you, Renee. Thanks for helping out here today. He's in the Philippines, so I don't think it's snowing in the Philippines. Austin is here, so he's probably getting some snow as well down in Denver. Tim, nice to see you. So rainy in Minneapolis. Interesting. So if you're new to the broadcast, thank you for joining us. This is Food Safety Chat Live, and every Friday at 8 a.m. Mountain in snowy Colorado and 10 a.m. Eastern in balmy Florida. We have a broadcast where we do a live stream around a food safety topic. And if you're new to this, one of the things that you're going to see is that this is not a presentation. This is a discussion, and this is our attempt at sharing information and helping to promote food safety a little bit. So every week we have a new topic. If you have a suggestion for a topic of something you'd like us to talk about, we would love it. So as you can see on here, our emails are at the bottom. Just fire us a note and say, hey guys, I would love you to talk about the environmental monitoring or what FDA is up to, or infant formula shortages, whatever it is that's going on out there in the world. Let us know. We'd love to talk about it. So Richard, new face. Good morning. Thanks for joining us. We appreciate it. Chicago, beautiful city. Chicago is always a fun place to go. Haven't been to any conferences yet this year, though. But it definitely seems with GFSI and these type of things, Jose, that they're coming back. They're coming back, which is great.
Yep. Actually, the SQF conference this year seems that it's going to be on site.
Mm-hmm. Yeah, I saw was it. So the Food Safety Summit had theirs, right? GFSI had theirs. So that's what's nice about conferences, right? It's kind of what we're doing here as well, right? You get to go out and meet with people who have shared interests with you and share information and best practices, and that's how food safety gets better, because we're all in this together. We may work for different companies or be consultants like Jose and I, but we're all after the same objective, and that's to protect public health and make sure that the food we eat is safe. So super important. John, metal detectable plastics. Yes, we're seeing more of those, aren't we? So tools with metal embedded in them and things like that, metal detectable gloves and bandages and things like that, which is a good thing, right? You want those type of things, but too, and if you're a past viewer on this, one of the things that I've mentioned before is when you look at recalls from FDA, more than half of recalls are for non-metal foreign material. So metal detectable plastics are helping with those type of things, but there's still lots of things in your processes that can cause a recall. So don't forget those guys too.
Yep. And actually, Brian, now that you're mentioning that, the FSIS also has a lot of recalls for plastics and metal, foreign matter.
Yeah, absolutely. So definitely, if you're involved in food safety, you have to really watch out for that. So one of the things that we like to do here in the Food Safety Chat is to have a little ceremony together.
Oh, yes.
And so please join us for a ceremonial My Coffee, Jose's tea, and join us for
I have a nice tea today.
Join us for a sip. Wonderful. So last week we did not have a food safety chat. I apologize about that. COVID. I got COVID. My wife is a pharmacist, and she picked it up at work and brought it back, and we were both been suffering through that. We were lucky though. I mean, this is the first time we've got it. I know some people who've had it 3 times, and on the tail end of this, so I've been having some coughing and things like that. So hopefully I'll be okay. Got my cough drop and everything else. So we'll forge forward. Um, John said we were the guy who came up with the concept 35 years ago. From the metal detectable plastics. Nice, very good. So Jose, so one of the things that we do every week is we kind of dive into a different topic of interest to the food safety community. And what are we talking about this week?
Oh my goodness, Bryan, we are going to get deep into how to select the proper critical limit. And I don't want to say critical limit. I prefer just to say criteria. That's how I learned that in the university. But okay, I mean, we're in food safety, and most of the people are going to feel kind of related to the word critical limit. That's our topic today.
Yeah, it's there's a rule, right? And so early on in my career, I read some really good books on negotiating and things like this. And one of the rules of negotiation is that people believe things in writing much more than things that are said. Okay, so that's nice, Bryan. But what does that have to do with anything? Data, graphs, charts, information is super valuable, because you have to remember one of the key success points of your career and being able to have a good career in food safety and quality is to be able to explain to non-technical people in sales and marketing and executives why things are the way they are. And if something isn't quite right, why it's not right. And I remember back at one of my previous companies, Jose, we used to have a quality questionnaire where we would gather data from our customers. We would put the questionnaire in the product and get back data that could go on the website and answer a unique survey. And it was only quality related. And this data was gold. It was absolute gold, because the consumers would tell me what the primary defects were. I could figure out the age of consumption of the product. I could see the graph of the score of the product over time. And we knew exactly where to put the shelf life. Now, within business, as you know, shelf life is extremely important to the success of your business, because if your shelf life is too short, you can't sell your product and you end up throwing things away. And there's a constant tension in companies of, oh, can we have a little bit longer shelf life? Because if we had just 5 more days, then we could sell more product and blah, blah, blah. And that data, Jose, was oh my goodness. A salesperson would say, I need 5 more days. And I'd be like, I understand why you need 5 more days, but let me show you on this information what will happen if we do that.
Yes.
And they would look at that data and go, yeah, I see what you're saying. Let me see what R&D can do to maybe reformulate to extend shelf life. Okay, that's a good idea.
Yep.
And that pressure of, quality, can't we have just a little bit more shelf life, went away, because I had data to show why we couldn't have longer shelf life.
Yeah. And many times, Bryan, you can also use that same data in order to talk to customers, because they may at some point want something that is just impossible.
Yes, exactly. And regulatory. So one of the things, if you worked in food safety for a while in food quality, is weights and measures. Right?
Yeah.
So as we know, right, the NIST, the National Institutes for Standards and Technology, has documentation on weight control and maximum allowable variation for products. And there are states, New Jersey comes to mind, North Carolina, definitely. So inspectors will go out and pull products off grocery store shelves. And they have a little worksheet, and they'll work through that and look at the weights that are printed on the packaging. And they'll say it's a 6-ounce piece of cheese or something. And then they'll tear it and weigh it. And if it is too low, they're like, aha, this company is trying to rip off the consumers. We're going to fine you, right? And then I would get the letter and have to show evidence that we weren't, because there's variability in your process.
Yes.
Not every piece of cheese was exactly 6 ounces. It's a plus or a minus, right? So you have a bell curve. And I would show that data because it was based upon lots. And so generally a production day was a lot. And I would have data then to go back to these states and say, no. That one piece of cheese that you sampled was just a little bit below the average, but here's the average for the entire run. This lot is in compliance. We're not going to pay this fine. And then they would go away, right? But if I didn't have that data, I had no defense.
Yep. Yep, that's exactly right. And one of the things that you just mentioned, Brian, is a fact about processing. And when I'm saying processing, could be processing or manufacturing, or you call it as you wish, is that fundamentally each and every single piece of equipment is going to have its own variation.
Yes.
Okay. And we need to understand that variation in order to make sure that the outcome, according to the combination of variations throughout the process, we are going to end up having a product that is in compliance with its own specifications.
Mm-hmm. And in that last statement was a super important word, and that was variability. And that's been a real challenge in the food industry. So I'm a Six Sigma black belt. We went through training and all these types of things in the past company I was at. And we had difficulty really getting down to some of the more technical tools associated with Six Sigma and process capability, because the food process is so variable, right?
Yes.
So if you're applying Six Sigma to automotive parts or things like this, where you have very, very tight tolerances, then you can really get down into these type of things. But if you're making cheese and the milk you are getting in the spring is completely different than the milk you're getting in the
Yeah.
fall, your process is constantly changing and evolving, and you
Yeah.
have to be able to go with the flow. And that variability in your process is cumulative, right? It's just not, oh, you're
Yes.
just one piece of equipment, right? It all adds up through your process, and it can make it very challenging.
And you mentioned the milk in the spring and the milk in the summer or autumn or whatever that is. Let me
Uh-huh.
give you one more. The four seasons. Do you think that your equipment is going to work exactly the same when it's winter time and then when it's summertime?
Yeah.
No, it's not.
Exactly. Yeah. So I work with a company, and they do like a liquid pea protein drink. It's a wonderful product, and they have sleeves that are blown on and then shrink wrapped onto the bottles. That machine in the summer, to your point, when it's hot and humid, works completely different than the winter when it's
Yes.
cold and dry,
Yep.
because now you have condensation, and that sleeve going on is much more challenging. So your
Yes.
variability is different.
Yes. Yes. And those are, I mean, that is a very good example on things that we need to take into consideration whenever we are dealing with these uh, common variation or special causes of variation, which
Ah,
is now, and you know these because you're black belt. I was not aware that you're black belt, but these are typical things in engineering that we learn and we use in order to try to understand the behavior of the process, which at this point for this chat, I'm so used to the class that I cannot. So that for this chat, we're going to try to explain how these things are related and that conversation about how to decide a critical limit or how to decide an operational limit, which is what
mhm.
everybody should be doing each and every single time that you select something that is going to be critical, how to do that.
Yeah. And so one of the important things with when you're looking at this data and you're deciding how am I going to use this in the process, there's two key criteria, Jose. All right, is this something that I'm going to be using on the line for
Mhm.
process corrections? Or is this data that I'm going to be compiling for later analysis to evaluate the process? So you need to understand that really clearly. And I think a good example of this is control charts, right? One of the things
Yes.
that's pretty common in the food industry
Yeah.
is weight. Let's say weight. We'll stick on the weight topic, right? So weight control charts and setting those up.
Yeah.
And I actually found this is from a company called Infinity QS. So I'll give them a shout out. And you have like cards like this, right? Where you
Hmm.
have your little process capabilities, right? And you got your run chart. So this guy here, so I've had this card a long time, and it's been super valuable. And run charts like this, I wanted to kind of talk about run charts and why these guys are so valuable.
Yeah. So that is, more or less. If you want, we can start trying to dive into this right now.
Oh, your choice, however you'd like to proceed.
Okay. So let's try that thing that we were trying before we,
Yeah.
get live. Share my screen,
Here we
Brian,
go,
please.
guys. Fingers crossed. Let's see if this
Yeah.
works. Hey, look at that.
Okay. So
All
it's
right.
going to take a little time, guys, because I'm drawing in my iPad and that goes to the cloud, and then goes back to the computer, and then goes back to the StreamYard through the chat box. So what I'm going to do is the typical approach whenever we are working with I'm going to say a critical limit. Okay. At the end, you are going to see that we should never work with a critical limit. We should be always working with operational ranges. Okay. At the end, that is the deal. That is going to be the summary, the conclusion of this chat. So on your screen, you have a graph. Pretty bad graph. I draw it by hand, but to my point, the first thing that we normally are going to do is to try to identify, and this is going to take a little bit of a time while it shows up on your screen. I'm going to start drawing here. But the first thing that we're going to do is to try to identify what is a critical limit of whatever we're doing. I'm going to use, for my convenience, for this explanation, the cooking of the chicken, and we are going to use the FSIS document, FSIS schedule. I believe it's a schedule B, schedule A, schedule B, that defines which is the right temperature in order to cook salmonella in chicken. Okay, in order to get an instantaneous kill of the salmonella. So fundamentally, let me see if I can update this.
Oh, there we go.
No, that is the one that I draw as a final in case that this is not working. but look at this. It's not showing, unfortunately. Well, let me go here and let me show the one that I prepared for you.
Okay.
So the first thing that you guys are going to do is look for the food safety. That is the reason for FS, critical limit. And the source in this case is how to cook the chicken properly to make sure that there will be no salmonella.
Right.
That means that the number, according to documentation, is 165 or more. Okay. That is the reason why this dark blue line is at the bottom. We need to be above that number, according to documentation. Okay. So you know that you need to be above 165. Now, what you do not know is that what is the real number that you need to use to monitor that operation. And the first reason is that, as you can see in green here, okay, this is your process variation. And I added here, a little, kind of a note to make sure that you understand what is this. What we are supposed to do is to check the equipment and understand what is the process common variability, the common causes of variation in our process. And as you can see, you're going to have a lot of different points, exactly what Bryan was explaining a few minutes ago about weighing. It's going to be impossible that you're going to get exactly the same weight all the time whenever you are performing that activity. So you need to understand what is the typical variation whenever you are weighing. In this case, we need to understand the typical variation of our, I don't know, I'm going to say oven or fryer or I don't know, pasteurization process, whatever we're using. It doesn't matter.
Because the chicken going in is at different temperatures. There's different temperatures. Let's say we're cooking in oil, right? There's different temperatures in the oil. There's variability, right?
Yes.
Yeah.
And look at this, Bryan. Now that you're talking about oil, let's say that we are frying this chicken. Well, the point here will be how's the setup of the equipment? Do you have one large burner all under the device, the container, the tank with the oil? Do you have 3 different burners on the lower side? And as we know, whenever you heat something, heat is going up and cold is going down. But that's how that works when you have that oil that has different burners in different places. Are you getting the right temperature everywhere in that tank? No, you are not.
That's a good point, right? So as I'm visualizing this, right, you're getting convection currents, right? So you got hot
Yes.
oil in the bottom and it's coming up and then it's rotating out and going down the sides where it's cooler. So different temperatures, right?
Yep.
Yeah.
Yep. And when you are exposing the product to that variation in temperatures, well, you need to take that into account, because whenever the difference between the temperature of the product and the temperature of the oil is very large, you are going to get a very steep curve heating up. But whenever
Mhm.
that difference is kind of a short, you are going to get kind of a very small variation, and that may affect the effectiveness of your cooking process. In this case, the frying of the chicken.
Right. Well, and then also the pieces of chicken themselves are different sizes, right? So it's going to take more time for heat to get into a bigger piece of chicken versus a smaller piece of chicken.
And right now, I'm just discussing the critical limit, but that is
Yeah.
one thing that we need to define if we're going to be frying the chicken. What is the maximum size to make sure that this variation is going to work?
Yeah.
Okay. So, according to statistics, we are not going to get into this right now, but any one of us that have this background, we can go into your equipment and identify and collect the data to understand what is the typical behavior of your equipment. In this case, it's going to be the fryer, let's say. Okay, what is the typical behavior? When we go there, we need to understand if you have cold spots and if the product is going through those cold spots,
Hmm.
and more or less understand that is basically the job of a process authority. Go there, understand the working conditions of the equipment, understand the typical variation of the temperature throughout the equipment, especially in those areas where the product is, I'm going to say in this case, flowing through. What kind of mechanism the company is using to move the product? Are you using a pump to move the oil and then the product is going to be pushed? Are you using two screens that are going to basically grab the product, immerse the product into the oil, and moving the product away? We need to take that into consideration. What is
Yeah.
the temperature, the typical temperature of the chicken when the chicken is going in? Okay. Remember that we're supposed to have the chicken below 40 all the time in order to prevent any excess growth of salmonella. So, what should be the temperature when the chicken is going in? Well, should be, I'm going to say around 40, maybe 41, maybe 42, because it was cut in the previous step or something like that, but it should be very cold. Now,
Hmm.
the oil is very high. This is going to create some kind of a delay in the chicken getting to that temperature. Now, can you heat up the chicken in order to put it there? Oh my goodness, I don't think that you should be doing this, because now we have a food safety issue.
Hmm.
So, to my point, Bryan, in all of these years, I do a little bit of process authority work. And all of these years, the problem is that people say, Jose, can you please come here and perform this check? Yes, I can do this. I can determine the variation of your equipment. Okay.
Hmm.
But then after testing once or twice, they say, okay, done. You say, no, you do not have enough data to determine if we actually have all of the points, especially those that are very up or very low, in order to determine what is the right average,
Right.
because we don't have enough data for that.
Well, part of this too, right, is that let's say that you have a production run and you're running for 12 hours a day. The temperature of the oil at the beginning of the shift is going to be very different than the temperature at the end of the shift as the equipment heats up and runs during the day and all these type of things, right? So you may have more variability at the beginning of the run versus the end of the run, right? You need to gather all that data.
Yes, yes. And if
Mm.
it's winter time, it's going to be very difficult. And if it's summertime, oh, this is going to be very easy. And eventually, in summertime, you're going to get very good readings. And in wintertime, you may need to adjust the fire that is heating up the oil in order to get the right temperature.
Yep. And here's the crazy thing too, is that there's an assumption with equipment that that variability is standard, right? And then it always stays the same. And
Mm,
that's not true either, because you can have two identical plants with the same identical equipment in those plants designed exactly the same, and those processes will still operate differently.
yes, Yes, 100%. And by the way, Brian, and this is from personal experience. Let me give you this example for the heating up. So when I was in South America working for my family, we were processing blue crab meat and we were pasteurizing blue crab meat in a can.
Okay.
Okay, so how do you do this? Well, you put the blue crab meat inside the can, you seal the can, and once the cans are all below 40, you throw them in this very long water bath.
Hmm.
The water, the temperature of the water must be, according to FDA, 185 or more.
Hmm.
Okay, just that's what I need to assure in order to get the right lethality. Let's put it like that. Okay. So I remember that when we set up the tank initially, and I'm talking right now, 1990, what, 90, 95, 96, when we got the alert that, oh, the FDA is setting up the seafood HACCP and we need to validate the process, whatever, and that is applicable to people outside of the United States. So, oh, we need to validate the process. So I
Hmm.
start throwing some thermocouples inside the tank, trying to identify the cold spots, and then moving the cans. We realized that as soon as you put 100 pounds of product that is at 40 degrees in water that is a 187, 188, 180, whatever, that
Uh-huh.
water at that point is going to drop. Oh, and we were not able at the beginning in order to wait long enough in order for the water to recover. So we need to set up the tank with some pumps, and the pumps were trying to recirculate the water. And it took me significant several months to adjust the equipment to work the way that I wanted. Now
Hmm.
look at this. After years of operation, sometimes when I was checking the data, because we collect that data and we keep that data forever. Okay. And I saw a trend that, oh my goodness, every time that we're placing the basket, it's taking longer for the water to reach, the right temperature. What's
Yeah.
going on? And then we start performing investigation. And guess what? The water is very hard. Okay. So when we
Mm.
have the boiler to heat the water and the steam that is going to be used to heat up the water, the pipes were getting accumulated with the incrustation. And the diameter went from 4 inches all the way to 2.5.
Wow.
There you go. So for the validation and the annual, and eventually not even annual, maybe every 6 months, maybe a year and a half, I don't know. But there should be some frequency of revalidation because of certain things that may happen to the equipment,
Hmm.
natural wear of the equipment. We need to
Yeah.
take that into consideration for variation.
Yep. And every process has that variability, and it also depends
Yes.
upon, and this gets into why calibration is so important. And if you have a, let's say, a probe in that tank that's monitoring that temperature, and that probe is not very accurate, right? That's going to be switching
Oh,
on
we're
and
going
off
to
at the
talk
right
about that.
time at the wrong times. And let's say that that probe is right next to the inlet for the hot water going into the tank.
There you go.
But clear at the end, there's a cold spot that you don't know about
Yes.
because it doesn't measure there, right?
It was not properly designed, the equipment,
Mm.
because the pros will always go in the cold spots, not the hot spots.
Yep, exactly.
Yep.
See, Kimberly had a good comment here. The shape of the chicken meat is another variable. Thickness of the thigh versus
Yes.
the wing. Oh, 100%,
Yes.
100%.
Yes. And that's the reason why we said that. I mean, one of the, I'm going to say, critical aspects of this is going to design the shape of the chicken before we decide to, cook it.
Exactly.
So,
Steve had a question here as well, Jose. Let's see here.
sure.
I do have a question about partially cooking raw chicken with a searing machine prior to cooking in a bag. The cook in bag step is our CCP. Can I get your email to further pick your brain on the subject? Absolutely. Yeah.
Yeah, my email is below my name.
Yep. Yep. Reach
Steve.
out to Jose. He's an expert on this.
Yeah, yeah, that's a very good question. That's a very good question. Okay,
Mm.
so let's say, which is the point that I want to reach for today. Let's say that we gather enough information, and when I'm saying enough information in statistics, unless you have at least, and I'm not comfortable saying this, between 75 and 100 individual readings, you start getting into more or less guessing what is going to be the behavior of your process.
Mm-hmm.
But you're going to get very, very good approach whenever you start getting above the 500 and whenever you go above 1000. Oh my goodness, that is just amazing what you can guess about the behavior of your process.
Yes.
Okay. So let's say that we gather the first 100. And because of that, we are going to use statistical process control. When we draw the average, you are going to see the green line here. Mm-hmm. This is the new critical limit that is above the one that you selected from the documentation. Okay. And you're going to be using that because you need to be a little above because of the natural variation of your process. Mm-hmm. So that food safety average, because of the variability of your process, is already the concept of an operational limit. Okay. Mm-hmm. So with that, we are done with the food safety variability of the process in all of those details. Now we're going to get into the third variable that we need to take into consideration, which is the food safety operational limit. And you're going to say, why, Jose? This is making no sense. Bryan already said this because of the accuracy of the equipment that we're using. Okay. And I'm going to use an example. Let's say that the one in blue is 165 because it's what we get from Schedule A, Schedule B of FSIS. Let's say that the one in green is 168 to say mm-hmm. something, it's a little bit more stringent. Now, when you need to measure 168, because you know that 168 is going to somehow be 165. Is potentially this is going to be your critical limit. Hopefully mm-hmm. not, but this is something that needs to be measured at the end. So at that point, you need to take into consideration the accuracy of the instrument that you're using to measure your process. Okay? And when you do this, I'm just going to use as a crazy example here for everybody today, that for the food safety operational limit, I'm going to say the thermometer that I'm using is, if you look at the manual of the thermometer, it says plus or minus 2 degrees. So mm-hmm. what that means, that if we choose 168, okay, and there is the monitor, and the monitor is actually reading the temperature of the chicken, and it says 168, according to the manual of that thermometer, that number is 166. Because there is a natural variation of the equipment according to its construction and working conditions, by the way.
Yeah.
Okay. So because of that, we will need to go 2 degrees up in this measurement. And this food safety operational limit, according to the accuracy of the instruments, is going to be, to say something, 170. Mm-hmm. Okay. So look at this. Because now there is something that is not here. 170 is your critical limit. It's not the operational. It's the critical, because if you deviate, if you measure anything below 170, due to the accuracy of the equipment and due to your process variability, you will be at 165. Because you already measured that. Mm-hmm. We have the evidence for that. So now this one became your food safety, and it's not the operational. Everybody thinks that is an operational. It's a critical limit. So if you want to have some sort of you know what? I want to have a little bit of a caution here. Oh, I'm going to cook at 172, 173, 174, or a little bit up. And that is going to be the operation, the real operational, whenever you have a caution. So if you have a minor deviation, yeah, you need to correct the process, but the product is fine.
Right.
The product is not adulterated.
Right. And so that's an important lesson, right? Is you never set your food safety operational limit at that limit. You're always above. There was, based upon the data, for your process. There was a recall a few years ago so similar to your product with the blue crab, right? There was a canning type operation. And they didn't take that variability into consideration. And so when they were inspected by the regulatory agency, they were actually below and they didn't know it. And they had to recall everything.
Bryan, to your point, years ago, I was performing an SQF audit, and these guys were having a new process for a new product. Of course, all the information here is confidential, so I'm not going to mention names or products or anything. But, there was a process authority that went there and said the cooking temperature must be 165 or more.
Mm-hmm.
And this guy put some sensors, and I saw all the evidence. So this guy did a wonderful job. Now they have a PLC, they have a computer with wires and then a sensor that is located in the equipment. The wires are 0.1% deviation, very accurate. The
Mm-hmm.
sensor was something like a 0.1% of the reading deviation. And the equipment alone, the manual of the equipment alone says something like 0.5% of a deviation. So you can actually say that whatever you're reading on that screen, it basically is the real value.
Mm-hmm.
Now look at this. When you connect the PLC with the cable and then with the RTD with the sensor, and they call a company with calibration services, and they calibrated all the equipment all together, they have a plus or minus 2 degrees different.
Mm-hmm.
What about that? Just because of the connections and the working conditions and so on. And they never realized this, and they set up the critical limit as 165. Thanks God that by the time that I was auditing, they were starting the process. And guess what? I raised a critical nonconformity at that point because the product was being adulterated.
Yeah. You have to understand this. You have
You
to
need
understand
to
the process.
understand the process. If you don't understand how the process behaves, you most likely are going to produce adulterated products.
Mm-hmm.
Okay. So now, okay, we have what most of the people are going to say, okay, that's it, I'm done. Well, actually, you are not done. And I'm going to use this, silly example, but to my point. So let's say that all of us here in this chat, we want to prepare some bread and bake some bread. And we're going to set up our oven to 350, and we're going to put the bread there for whatever, half an hour. Let's say that we validated all of those numbers. Okay, 350, half an hour, done. Are we going to be, hopefully, by setting up that temperature, most likely we are going to be around here. 350 is in the 30 minutes. Most likely it's going to be more than enough to bring that bread about whatever temperature required to kill, most likely, Salmonella and E. coli. Okay?
Mm-hmm.
So, fine. The bread is safe. Now, let's say that we want to create an operational limit. We want to create a gap and say, you know what, we want our bread to be safer than anybody else, and that's a reason why we want to do something to improve the safety. Or you know what, I'm going to make the safest bread in the entire world. I'm going to set up the oven to 500 degrees, and I'm going to cool this for 2 hours. Is that bread safe? Oh my goodness. I don't think that nobody is going to, ever die or get sick or anything because of that. Maybe from the burnt, and you can basically use the baguette in order to kill someone if you hit someone on the head. So
Yeah.
you already lost the quality of the product. So to my point today, once you define what is your operational for food safety, now you need to identify what should be your operational for food quality. And for food quality, you are going to fundamentally do the same, but instead of starting from the bottom, you're going to start from the top. On the top, you are going to be try to look, which potentially you are not going to have this information publicly available. Most likely it's going to be your own testing at the facility.
Yes.
To identify what is the critical limit, understand what is the typical variation of your process at that temperature, because you know what is the variation here, but the variation at different temperatures is going to be different. And this is another thing that people don't know. So we need to find what is the typical variation at that level, and then understand what is the typical accuracy of the equipment that we're using. And between this light blue and the yellow is where we are going to define our operational range.
Mm-hmm.
And what we're going to tell the monitor is the temperature must be above this and below this. And the range of time is going to be minimum, whatever, 25 minutes, maximum 30 minutes. And that is fundamentally why you have these type of things. Bryan.
Yeah, and so Jose said something I want to emphasize, right? So you're looking at this from two different parameters, right? So first is food safety, right? There's a hard line. You cannot violate that under any circumstances. Yes. And you need to make absolutely certain you understand your process and that you're always above, or whatever it is for that parameter, you're always safe, right? You have a buffer within there to account for that variability. And as Mark says stacking tolerances. So
yes,
these type of mistakes are additive, right? They all come together to come into this big picture. The other one then is quality, right? And so just as important is that quality piece of that. And this is where that statistical data can be extremely valuable, right? Yes. A lot of times we hear in quality, Jose, people saying, oh, geez, the operations people don't understand what I do in quality and they don't understand how I help the business. This is how you help the business.
Yes.
Right. So if you understand, let's stick on your bread example, that, okay, I've got my food safety limits set up now, and I understand the correct baking parameters and my process variability, and I can set my ovens correctly for time and temperature. Now, how do I manage quality, right? So your overall goal is to squeeze that bell curve, right? Yeah. So you need to understand your process and then take a look at that data and say, okay, do I have normally distributed data? Do I have data that tends to clump around the control limits? What does my data look like? So that you can figure out what's that plus or minus. And let's stick with weight, right? Something simple. So I have a target weight, and then I have a plus or minus associated with that. Then I've got my limits of where I cannot go outside, right? So as we talked about earlier, right, there are legal requirements for maximum allowable variation and your label claim associated with that weight. So you need to understand those values, because then you can hopefully improve that and understand where that variability is coming in the process. Yeah. So let's say for making that bread, you're monitoring the process and the machine that cuts the dough into loaves, right? You're looking at that variability there because that's directly impacting the weight of the finished product.
Yes.
And then you're able to dial that in and reduce that waste. Now you can show that data to management and say, based upon this, we can run at plus or minus this. And based upon this new piece of equipment, we've improved it this amount. We have an ROI on that. We could justify the purchase of that. And our process capability is much better, and we're saving the company money because we're not giving away products for free above stated weight.
Yes.
And now the operational guys are going to be, I see, right? Yes. And now you're using this data for the betterment of the company.
That is right. That is right. And you know what is your typical variation. So to your point, whenever you understand what is the typical variation in your process and you draw your curve, what you need to do is, okay, where are the specifications of my product? Are the specifications of my product within the limits of my process, or, which is the one that you should not be using, the specifications of my products are outside of the capability of my equipment. At that point, you cannot produce that product because you will never be able to produce it. Equipment is not capable of achieving that.
Exactly. And you need to understand that directly on the line. So it gets back to what we were talking about earlier, right? There's data that you can use for analysis of your process for improvements over time. And then there's the actual real world on the line, the operator is running the equipment data, right? And that's where these run charts and control charts become so valuable, right? So let's say that you have that operator who's making that bread, and you say, okay, I want you to pull off every 15 minutes, 5 loaves and weigh them, right? And then chart that information. And a lot of times operators are like, geez, I'm so busy, I don't have time to do this, right? And that manual process can be a challenge. But the operational team has to understand that is job one, right, for understanding the process. Yes. Because if you don't understand that capability and you need to figure out using different run rules, am I headed in the right direction or not? Because the whole
Yes.
goal is to keep it in that range. Oh, no, get it back down,
Yep.
right? So that you're maintaining that over the course of the run. Because part of this too, and we didn't talk about this in the conversation yet either, is variability can vary, right? So
Oh, yes.
you can have different variability at the beginning of the run versus the middle versus the end of the run, right? And you need to
And
be able
during
to
the different
manage that.
seasons of the year
Yes.
and at different altitudes.
Right. And so part of this too, right, is so this is where these control limits are so valuable. So let's say that for your operational accuracy limits for your quality standard, you're going too high, right? Well, now you're just giving away product for free. And if it goes too low, now you may be below legal limits for the declarations of the weight on that product.
Yes.
You need to find that out right away, because the last thing you want, and this is something, Jose, that drives every quality manager insane, is, oh, hey, Bryan, we have an entire production day of bread in the warehouse that's low in weight. What do you want to do? What do you mean, what do I want to do?
There is
Don't make
nothing
it.
you can do.
Yeah. Why in the heck did we make it? Right? We should have found that out immediately on the line. Why did that not happen?
Yes. Yes. Because at the end, Bryan, and these are the typical controls that when you understand in engineering the flow of your process, there will be certain parameters that are going to be measured at each and every single point that will kind of release the product to the next step in the process. So
Yes.
if they can catch that the bread is underweight and they're starting the day, they're going to say, hey, hold on, stop. The bread is underweight. We need to do something. And at that point, you're going to be wasting just a little bit of the bread, which,
Yeah.
if you wish, you can throw it out because it's going to be a small quantity.
Mm-hmm. Well, here's an important point too, right? Is that person performing those measurements on the line, training them how to properly do that,
Oh my
right?
goodness, yes.
So, for example, I used to work in refined liquid sucrose, right? So we would measure pH on the liquid sucrose, right? So very low water activity, meaning that the pH meters would have a hard time doing that measurement. So you had to have
Yes.
the right equipment, and you had to have patience. So what I found out from doing some studies within our process, it could take up to 10 minutes for that pH to
Yes.
equilibrate. So the operators would pull a sample from the production line, go to the lab, boop, put it in the pH meter, hit the button, and a lot of pH meters are set up for an auto read at around 30 seconds. And they would get that reading at 30 seconds and write it down and run out. And I started looking at this variability in the process. I'm like, this doesn't make sense. So I started watching in the lab. And so I would make the operators wait and say, no, 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 no. Let's watch this for a while. And we watch the pH go up and up and up. And they're like, ooh, I'm like, yeah, right.
Yeah.
So can the operator stand there for 10 minutes watching the pH meter? No, right. So go to the lab, put the pH meter, put the sample in, go back to your line and come back in 10 minutes to get the final
Yes.
reading.
Yes.
Right. Huge, right? If we had reacted just on that wrong information and adjusted the pH on the product, it would have all been out of spec.
Yes. Yeah. Yeah. So again, Bryan, we're very close to finish today. Time flies, like always. To my point, defining exactly the working conditions of your environment, how you select your ingredients. Remember, your ingredients are going to natural variate between one shipment and the next one, between summertime and winter time, because there will be a lot of variation.
Yes.
Okay. And even if you buy the same ingredient from two different countries, that ingredient is going to be different because it's growing in different conditions. Okay. So, to my point, it is the job of the person that is responsible for the program to define exactly what is that operational range and try to connect the operational range of each and every single step of the process to check if they align with the rest of the step of the process. That's what we do.
Yeah. And here's an interesting little tidbit that I learned in the food industry for weight control that would probably apply to anybody. So there are certain retailers out there who have different contract criteria for weights on products. So for example, there's a large retailer who says, All of the product you sell us needs to be at stated weight or above. So for example, let's say you're selling that 6-ounce piece of cheese. What they're saying is no piece of cheese that you sell us can be below 6 ounces. Everything needs to be above 6 ounces. That's your lower control limit, is the stated weight. Now, as we talked about, Jose, you have that bell curve, right? Where when you look at your entire lot, you're hitting weight. Essentially what you've done is you've taken your entire process bell curve and moved it up. That is an incredible cost to the company. So generally it's between 10 and 15%. And if you're quoting to that customer and your sales team doesn't understand that, your price is going to be too low, because you're going to be giving away product, and it's going to be all of a sudden the finance people are going to be looking at the products and going, gosh, we're losing a lot of money all of a sudden. Why? That's why. This information, and right, so that little story, and this is a good way to kind of close on this too, right, is that these processes and these controls are extremely valuable to the success of your business, right? So from a food safety standpoint, of course, but from a quality and operational standpoint too. And if you can show this to the company of how this is valuable and it hits the bottom line, oh, they're going to love you.
Yep. And as a last example, Bryan, our canning machine, I mean, it was an old piece of equipment. So I was a little bit concerned because we were getting some kind of this is a common, but sometimes we get a common that is, oh my goodness, right on the 3 sigma, top or bottom, it doesn't matter, but right there, and say, oh my goodness, this machine is getting me crazy. So by adjusting and adjusting and adjusting and calling the guy and tracking the effectiveness of those adjustments, because I can see in my chart the outcome of the adjustment, at some point I was able to train the guy that is taking the readings. If you see any measure that goes above this number, call the guy right away and tell them that he needs to adjust this or that or this section of the equipment, whatever, because we were able to match the work orders and the things that this guy was adjusting with the outcome in our operations.
Nice.
That in engineering is called a preventive action.
Right.
Because we do not have a deviation right now. We can see, according to the trends, that we may have a deviation in the future because of the natural wear and tear of the equipment. That is the beauty of getting the data and using the data.
Right, because now you can see that trend and you can stop it, right? One of the challenges in quality, right, is, okay, I understand corrective action, but how do I do preventive actions?
Good point.
You're looking at it.
Yes.
You're looking at it.
Yep.
Right. Well, so to your point, Jose, yeah, let's kind of bring this back up and close out. And again, with this information, right, you don't need to solve world hunger right away, right? You don't need to execute everything that we're talking about. Start putting in smaller programs, start doing weight control studies, start looking at thermometers within your process, right? And build your experience and expertise in these areas so that you can then expand and learn and grow relative to these things, right? Because if you try and tackle this all at once, yeah, this is a daunting.
This is
huge, right? And in larger companies, you have continuous improvement metrics type departments that this is all they do. And you may not have time for that, right? So like most things in quality, right, focus on the important things first, right? So food safety, right? How do I make sure that my food safety is under control and calibrated and correct? Move on to quality, move on to operations, right? That's the best way to approach it. And again, right, is you don't have to think you have to understand all this yourself, right? Work with experts, work with people who understand these things, right? Jose is an expert in these areas. Work with like companies like our sponsor, EAS, right? And look at their information and bring in experts to help you, right? That's why, as Jose said, that's why there are process authorities, right? These guys, that's their entire career, is understanding these type of things and helping to build processes and systems that are stable and capable. And that's super important. So the more you understand about this, the more successful you're going to be in your career in quality and food safety. So a lot to cover for sure, but hopefully we're able to kind of break this down and give you some good advice on directions to go, right? So lots of things to watch out for, that's for sure.
Yep.
Any other closing thoughts, Jose? Or
no, I believe that we touch a very delicate topic today.
And thank you for the graphics. That was awesome. I'm glad that worked. That was a nice way to present it. So yeah, get out there. Numbers are your friends, right? That gives us in quality, right? That's the hard data where you can show that to somebody and say, this isn't my opinion. This is what the data shows, right?
Yes.
Hard to argue with that.
Yep.
So on that note, oh, looks like the snow has stopped. So that's kind of nice. Hopefully
Thanks,
we'll have a
God.
nice afternoon here. Everybody, enjoy your weekend. Thank you again for investing the time and growing your food safety knowledge. We're all in this together, and this is how we get better, and this is how we prevent issues in the marketplace. So thank you for attending. Jose and I greatly appreciate it. We're glad to be able to share information with you. So please join us again next week on Friday at the same time for the live stream. And please, again, right, if you have examples of things you'd like to talk about, let us know. Just hit us with an email. We'd love to talk about it. And we will see you back here next Friday for the next food safety chat at 8 a.m. Mountain, 10 a.m. Eastern. So enjoy your weekend, and we'll see you here next week. Thanks again, Jose. Great to have you, my friend.
Bye-bye. Thank you.
Bye,
Have a nice
everyone.
weekend.